In this video, we want to compile the solution to Physics 102, the 2018-2019 section of Imo State University. Now, the first question says, list three properties of lines of force. We list them. The first one is that in terms of mode of relative transition, lines of force do not intercept nor touch. Rather, they travel parallel to each other. The second one, in terms of direction, the tangent to the line of force at any point gives the direction of the field. The third one, in terms of origin, lines of force are continuous, starting at the positive end or positive charge and end only at the negative charges. The fourth one, should be in terms of strength or intensity. The lines of force are drawn such that magnitude of the field is proportional to the number of lines crossing a unit area perpendicular to the lines. The fifth one, in terms of appearance or nature, lines of force are imaginary. So any of these three, you can pick it as the answer. Number 1b says, at each point on a flat rectangular surface of length 25 cm and width 20 cm with magnitude of minus 100 Newton per coulomb, linking an angle of 50 degrees with the position vector, compute the electric flux for this surface. The next one says, draw the hysteresis curve and explain the various parts of the cycle. So for us to solve, from the question we heard that the length is actually 25 centimeters and the breadth or the width is 20 centimeters. So the electric field is actually 100 Newton per coulomb and the angle in question was 50 degrees. Now, if we remember that flux is given as EA cos theta. Now, from there, we can see that we'll say that area, because we don't know area yet, but we're given the length and the breadth. So, length times breadth or width, which is 25. We need to convert to meters. So, it will be times 10 raised to power minus 2. That's dividing it by 100 to convert to meters. Length, that's length, times width, or breadth is now 20 times 10 raised to power minus 2, or dividing it by 100. If we press that on the calculator, we're going to get that the area is 0.05 meters squared. So because of that, flux now becomes E, which is 100, times A, which is 0.05, times cos theta, cos 50 degrees. So if we multiply out, we're going to get that the flux is 3.21 volts meter. The next question says, draw the hysteresis curve and explain the various parts of the cycle. If we can just put a kind of sketch for it, it goes this way. So for the sake of time, I have to pause the video so this is what the sketch looks like, the hysteresis curve. So the curve OA shows initial magnetization of the ferromagnetic material until saturation is reached at this A. So when the flux reaches 0, or it is reduced to 0, B, this point, has the value called remanence at C. To reduce B to 0, we must forcibly disalign the domains by using a reverse external field. So the point D gives the cohesive force needed to demagnetize the sample E. So this sample E now is the saturation point in the reverse. So in this reverse, the saturation point, the reverse direction. So you now form a new path it takes to become E, G, K, A, as the current can now be measured. So that's the explanation to it. The next question says a 2.4 farad capacitor of area 1 times 10 raised to power 9 meters squared is desired. What should be the gap between the plates of the capacitor? Take permittivity of free space to be 8.85 times 10 raised to power minus 12 farad per meter. So from the question, capacitance is 2.4 microfarad, right? Okay, 2.4 farad, I beg your pardon. Capacitor is 2.4 farad. Okay, from the question also, the area is 1 times 10 raised to power 9 meters squared, and the distance d, let's use small letter d, distance is what we don't know. They called it gap. They want us to find the gap between the plates, and they want us to use this as 8.85 times 10 raised to power minus 12 farad per meter. So we have the formula that says C is equal to E naught A over D. We make D subject of the formula. D becomes equal to E naught A over C. And if we plug in the values, we have 8.85 times 10 raised to power minus 12 times 1 times 10 raised to power 9 over 2.4. If we plot, if we have to press that, we're going to get roughly 3.6875 times 10 raised to power minus 3 meters. That's the answer. The next question says, draw the magnetic line of force for a horseshoe magnet, showing among other things the poles and direction of magnetic lines. So for us to do that, we just do a sketch for a horseshoe magnet. Here it becomes the north pole, here is the south pole. Anyone you want. Okay, let's make up the south pole. Let's make here as the south pole, here as the north pole. If you still like, you can use this. So, but one thing that you need to understand is that the lines of force must go from the north to the south. It must go from the north to the south. So the direction. So it must go from the north to the south. So these are magnetic field lines around a typical horseshoe magnet. We can just add some on this side and add some. The next question says, considering your in-depth knowledge of electromagnetic induction, define a transformer. So the transformer is a device used for increasing or decreasing an AC voltage. How we construct it is as two coils are wound around a core of magnetic material. The primary coil of, let's use a primary coil, that's turns. Primary coil of NP turns is connected to an AC voltage which produces time varying current. So let's use IP for the primary current it produces. So it produces it in the primary coil. This current, that's IP, produce time varying magnetic flux, this with respect to time. So in the core, upon which both the primary and secondary coils wound, this changing magnetic flux induces an AC voltage of the same frequency in that secondary coil. So what we mean by that is that if this is a coil, an AC voltage, and then another coil. So here is the primary turns, primary coil. Here is the secondary, and then inside here there is flux with respect to time. So this is how a transformer, just a sketch of a transformer. So we have an expression that's the voltage in the secondary coil over the voltage in the primary coil is equal to the Nx over Np, because they are, that is equal to Ip over Is. So this is the secondary voltage, primary voltage, secondary turns, primary turns, primary current, secondary current. The next question says, an 8 microfarad capacitor is connected to the terminals of a 60 Hz AC source whose RMS voltage is 150 volts. We should now find RMS current in the circuit, then find the capacitance. Now, for us to do that, we know that RMS current is given as V RMS over the capacitance. We can't solve for two unknowns at the same time. So the thing we can do is to first of all solve the second one, which is to find the capacitive reactance, so which is given by 1 over omega C. And we know that omega is given as 2 pi f. So for us to get that, omega is given as 2 pi times our f frequency is given to us as 60 Hz. So if we calculate that with a calculator, we're going to get a 377 per second. That's what we're going to. So therefore capacitive reactance is now 1 over W is 377 times capacitance is 8 microfarad, so 8 times 10 raised to power minus 6. And if we press that in the calculator, we're going to get 322 ohm. So we can now solve for the RMS current, which is V 150 volts over 322 ohm. And if we press that, we'll get 0.452 ampere. The next question says, plot the instantaneous current and voltages, that's IR and VR, across a resistor as a function of time. What is the phase difference between the two signals? So for us to do that, we just have, if we begin with the V, and here is I, so sorry, it's supposed to be here. So while here is I max, here is V max. So here IR and VR, and this is T, we already know. So if you check, you can see that the phase difference is 0, since both of them are in phase. So because two of them are in phase, the phase difference is 0. The next question says, show from mathematical principles that for a sinusoidal applied voltage, the current always leads the voltage across a capacitor. Okay, for us to show that, let's just first of all make a sketch. If this is a capacitor connected to a voltage source, now the voltage across this capacitor is given as V max sine omega t. Now we can use the formula that C charge, that's a capacitor, sorry, is equal to charge over VC, because Q is equal to CV. So C equal to V, but V now is the voltage across this capacitor. So this is because Q is equal to CV max sine omega T. So the current across this capacitor is change in Q over dt, because charge is IT as well. So we have this thing now is equal to CV max cos omega T. You can use a trigonometric identity that says that cos omega T is equal to sine omega T plus pi over 2. Now that means that IC, the current across the capacitor, is equal to omega C V max sine into omega T plus pi over 2. Now we know that pi is 180, and 180 divided by 2 is 90. So because of that, we can say that current leads, because it has additional 90, which is this, leads by 90 degrees. So it leads the voltage by 90 degrees. The next question says, state the factors on which the capacitance of a parallel plate capacitor depends. Now the first one is that it depends on the area of plate. Second one is the dielectric constant. The third one is the distance, that's the plate separation. The next one is the permittivity of dielectric, and then the plate symmetry. These are the factors that it depends on. The next question there says, a length of wire 2.0 millimeter, a 15 meter length of wire 1.2 millimeter in diameter has a resistance of 1.8 ohm. What is the resistance of a 25 millimeter length of wire 2.0 millimeter in diameter made of the same material? Now for us to solve that, we know that from the question we have that the first resistance mentioned there, R1, is 1.8 ohm, and the first length mentioned there is 15, that's, we call it L1, is 15 millimeter, right? Okay, 15 meters. The first diameter, D1, mentioned is 1.2 millimeter, and the second diameter mentioned there is 2.0 millimeter. Then we are asked to find the second resistance, and then given that the second length is 25 meters. Now we can use the formula that says R1 over R2 is equal to L1 over L2 times D2 over D1 all squared. So if we fix the values, we're going to have 1.8 over R2 is equal to 15 over 25 times 2 over 1.2 all squared, which will give us on this side 0.6, 0.6, 1.8 over R2, here 0.6 times this other side will give us 2.777, let's make it 784 decimal places. So what we'll now have is, on this other side we'll have 1.8 over R2 is equal to, here we'll have 1.666 approximately, here 7. Therefore R2 becomes 1.6667 over 1.8, which will give us 1.08 ohm. The next question says, how can a galvanometer of coil resistance 30 ohm give a full scale deflection when a current of, here is really not clear, so we have to assume it's 15 milliampere, passes through it, be converted into a voltmeter reading up to 100 volts. So if we are going, for us to achieve that, if that's for us to convert a galvanometer into a voltmeter, we have to connect a multimeter to the galvanometer in series. Now, what is a multimeter? A multimeter is a large resistance resistor. On the other hand, a shunt is a small resistance resistor. So R is equal to V over I minus small letter r. The big R is the resistance of the multimeter, V is the potential difference across the circuit, I is the current in the circuit, while small letter r is the resistance of the galvanometer. Okay, now V in the question given to us will be 100 volts, and the I, we assumed it to be 15 milliampere, and then the small r, it told us 30 ohm. So for us to get this very well, okay, we'll have to plug and say R is now equal to 100 over 15 milliampere. So milliampere, we have to say times 10 raised to the power minus 3. That's milliampere minus 30. If we resolve that, R is equal to 6636.66 and so on ohm. So if we are, it will look like this. Just a sketch. This will be the galvanometer. It will be in series, the resistor, and then the current will flow this way. So this is what it will look like. There is the multimeter. The next question we're supposed to solve is really not clear. The diagram is not clear, so we're going to skip that. So the next one says, how far should an object be from a concave spherical mirror of radius 36 cm to form a real image 1/9 its size? Now we're asked to find the object distance, and we don't know that. So we can say that object distance, let's call it negative x, because it's a concave mirror, and we're given that the focal length is, first of all, they give us r, that's radius is 36 centimeters. So f is r over 2, which is 36 over 2, which gives us negative 18 for a concave mirror centimeters. So now the magnification given to us in the question, which is V over M, is, they said, is 1/9. So because of that, if we cross multiply, V over U. So if we cross multiply, we can see that 9V is equal to U, and U is negative x. So V now is minus x over 9. So if this is V and this is F, we can say that from the mirror formula that 1 over V plus 1 over U is equal to 1 over F. And 1 over V, which is, we have to reciprocate here, we have to invert. So we have to invert, which will now make it negative 9 over x minus, here we can use 1 over x because this is negative x, negative 1 over x, because negative plus positive gives us negative. So it's equal to 1 over, that's minus 1 over f, which is 18. So the LCM here is x here is 1 times this negative 9, the LCM 1 here times this negative 1 is equal to negative 1 over 18. So here we have negative 10 over x is equal to negative 1 over 18. Negative cancels negative, therefore 10 over x gives us this. If we cross multiply, we're going to have that u, which is negative x, or now x is now equal to 18 times 10. That's this times this times this. So which is 180 centimeters. The next question says, from the mirror formula, determine where the object must be placed if the image is to be the same as the object. That's the focal length of the concave mirror is f. So if we're going to do that, we're going to have this, the mirror formula, 1 over u plus 1 over v equals 1 over f. Now u is equal to v, and because of that we can say 1 over u plus 1 over u, we replace v now with u, is equal to 1 over f. And if the common denominator, which is the LCM, is u here is 1 times 1 1, plus u here is 1 times 1 is equal to 1 over f. So what we have here is 2u is equal to f. So because of that, it must be, for us to get that, it will be 2 times that distance. So what we're going to have, let's write it out. 2 over u equals 1 over f. So this cross multiply, u equals 2f. So if we represent it as, and let's say here is f, and here is where the image, or sorry, the object is standing, and it goes this way, goes this way, and it goes this way. Sorry, it's supposed to be a straight line, supposed to be a straight line. So this is the point. It will be the same, both of them are supposed to meet here. Actually, that's where both of them are supposed to meet. So the same image, as the same height, the same size as the object. The last question says, a ray of light makes an angle of incidence 40 degrees with a glass prism of index of refraction 1.52 and refracting angle of 56 degrees. Through what angle is the ray deviated by the prism? Does this represent minimum deviation? From Snell's law, we know that refractive index is given as sine incident over sine I over sine R. So if we make sine R subject of the formula, it is sine I over n. So sine R is equal to sine, from there, 40 degrees over 1.52. So sine R is equal to, sine 40 is 0.64, yeah, over 1.52. Then if we divide this, sine R is, if we divide both of them, we have 0.42. Therefore R itself is sine inverse of 0.42, which is 24.83 degrees approximately. Now deviation is given as the incident minus the refraction, which is 40 minus 24.83, which is 15.17, and this represents the minimum deviation. Please do well to subscribe to my channel if you have not, by clicking the subscribe button. Share the video to your friends. Thank you.